we are starting number theory, the basic of number theory. So आज हमने जो plan किया है, right? What we have to study, as I already said that, like number theory. In the number theory, we have to study divisibility rule, primes, induction, Pythagorean triangles, and sum of the squares of two or sum of the squares of four numbers. Then the congruence of the numbers, right? That we have to see, right? The binary and decimal integers form. And then we have to go for CRT. CRT is for Chinese remainder theorem, right? This is one of the best theorem we can say, right? When we have to solve the questions, right? Right, and then Fermat Wilson and Fermat-Kichki factorization and the phi function and tau and sigma function that later on we'll know okay, exactly what it is. And Euler P function, this is one of the famous functions, and the quadratic recursive, right? So this is the complete number theory that we have to understand, right? So like in a fast track we have to go. If you'll find anything like how to solve and all, so just you can ask there, sir, first slow down, we have to do this in different ways or something, right? And then we'll do that, right? So one by one. So if more students are joining, right, in between. So I'll start with the basics something, right? Then you all will be comfortable with like the first question I'm starting with the numbers, integers and factorization and all those numbers we are doing this. So 3 to the power 2008 plus 4 to the power 2009, right? Can we write this number as a factor of two number, or I can ask this, is this a prime number or composite number, right? आर्यन के सबसे पहले आएंगे क्या सर दिस वाज द क्वेश्चन ऑफ इधर 2008 और 2009 आर्यन
सर वही बोलने वाला था
so this is prime or composite that we have to say, right? Let's start with the basic one. Okay, good Katani. Can you may I start, everyone? Is this okay? If you all are comfortable, can I start this? Yes, Katani, please. Divisible by 5. How you are saying this will be divisible by 5? This is ending with 5, divisible by 7, using cyclicity. Okay, compose it, divisible by 7. So you are trying few of the numbers, like is this divisible or not divisible? So you are trying few of the numbers, this will be written in that form, right? But see, what is this question meaning? From what area they are asking this, right? So I can rewrite this as 3 to the power 2008 plus 4 into 4 to the power 2008. Any doubt or confusion?
No, sir.
Or I can say this is nothing but a square plus 4b square. Right, a square plus 4b square. If I'll add, right, 4ab minus 4a. And more precisely, I can say if I'm not writing this 2080 divisible by 4, so I'm not writing a square. I'm writing a to the power 4 plus 4b to the power 4. So that will be like, yes, yes, right? It will be easier to understand what we are going to do, right? So if I'm writing in this form, not writing the square, writing in the right power 4 form, right? When I'm writing this as a power 4 form, then I can say this is completely a square plus 2b square the whole square minus 2ab the whole square, right? Then this will be a square plus 2b square minus 2ab, and second number is a square plus 2b square plus 2ab, right? So these two are the product of two number, but careful, careful. Maybe the lowest integer is coming as 1 or minus 1. So that we have to check. If this number a, right, I'm writing this a to the power 4 means this is 502, right? So 3 to the power 50 to the square. So 1004 plus 2 into 4 to the power 1004 minus 2ab. No, this is not coming as 1, right? So this is not coming as 1. So we can say these two are the product of two integers and none of the number is 1. So this must be integer, and this is called sophism. You know this,
Yes, sir.
right? The form a to the power 4 plus 4b to the power 4. Right, directly we have to come to the conclusion. This is completely coming as Sophie German. Okay. So you'll find lots of question on this, right? This is simple one, but obviously, right, important point is ki you have to understand this you have to apply for the question, right? So this is for warm up. Now coming with the first question. As I said, I'll start with the divisibility rule. So n to the power 5 minus 5n square plus 4n is divisible by 120. That we have to prove. It's a simple, but obviously, so n to the power 5 minus 5n square plus 4n is divisible by 120, right? Now we have to see exactly what we have to do and how we can apply the forms. Is this divisible by or not? If divisible, then how you have to prove this? Is this divisible by 120 or not? So just you can try with the numbers. First thing, you can try with the numbers. So if I'm writing 1, so 1 minus 5 plus 1, so this will be 0. Okay, like possibly this is divisible. For n is equal to 2, I can say this is n to the power 5 means 2 to the power 5 minus 5 into 2 square plus 4 into 2. Is this divisible this time? So you can say 2 to the power 5 is 32 minus 20 plus 8. No, not divisible. So this is called the induction process. When we have to see with the numbers exactly the numbers are working or not. If numbers are working, then we have to go for n and n plus 1, right? I'll just show you. So this is not divisible, but if I'll change this power, the simpler power with cube. Now see, is this divisible by 120 or not? Right, for you can say for few integers, I can say for 1, this will be 0, obviously. For 2, this will be 32 minus 5 into 8 plus 8. So can you see
Divisible.
divisible, right? This is coming as 0, so this is divisible, right? So for like for 2, this is, so maybe this will be, maybe there would be a problem for and 3, 4, 5 or some other numbers, right? So we can't say after putting the numbers 1 or 2, okay, this is always divisible, right? Now we have to make sure that we have to apply something where I can say that 100% this number will be divisible by 120, right? So we have like for subjective examination, obviously we can go with the inductions, right? What is this induction? Induction process is something is true for n, then we have to prove this is also true for n plus 1. If I'll show you, let's simple question I can show. N plus 1 is divisible, or n plus 1, n plus 2 is divisible by 6, right? That I have to prove. So let's suppose we are assuming that n plus 1, n plus 2 is divisible by 6. So this I can say this is something 6 lambda or something number is coming. Lambda is an integer. So from this I can say this is coming as n cube plus 3n square plus 2n is equal to 6 lambda. Now, this for, if this is true for n, this is true for n for n plus 1. For n plus 1 means I'm putting in place of n, I'm putting n plus 1. So in place of n is n plus 1, n plus 2, and n plus 3. Now this is coming as n plus 1 into n square plus 5n plus 6 and multiplying n cube plus 5n square plus 6n plus n square plus 5n plus 6. Or this is n cube plus 6n square plus 11n plus 6, something like this. Check this out. Right? Now, what we have, we can say for n cube, I can write n cube, the value of n cube is 6 lambda minus 3n square minus 2n. Can I put this value on this? What I am getting? 3n square plus 6 lambda n cube is 6 lambda minus 3n square minus 2n plus 6n square plus 11n plus 6. You can see this is 6 lambda, that is divisible. 3n square, cancel out, this is 3n square plus 9n plus 6. Is this okay? This is divisible by 6, this is divisible by 6. Now we have to say this must be divisible by 6. You can say 3 is common out, n is common out. This is coming as n into n plus, right? Can we say that this number is, right, we can rewrite this number as this is divisible by 3. So this must be divisible by 2, right? So n into n plus 3 must be divisible by 2. Is this even, right? Can we prove this? This is even? Yes, we can. I can factorize this 3 as 2 plus 1. This 2 is multiplying with this and n plus 1 this. This is multiplication of two consecutive number. What is the meaning of that? Multiplication of two consecutive number is always even, and this containing the number 2. So this is again even. So I can say this number is even and this is divided by 3. So overall the number will be divided by 6. So this, like, this is called the induction method when we have to use the entire thing. This is one of the linearist method, right? We have to go for all this thing, right? Every time when we have to prove, first we have to go for n cube, then we have to go for all the other things. So this is very good method, but not very effective method for our examination, right? So what should we do, right? So what we can say in this, right? The question given, this one, right? See, the basic concept. We have to understand exactly how numbers work. N plus 1 is divisible by 1 into 2. Can I say this? N plus 1, n plus 2 is always divisible by 1 into 2 into 3. Then n plus 1, n plus 2, n plus 3 is divisible by
4 factorial.
very good. So n plus 1, n plus 2, n plus 5 will be divisible by 1, 2, 3, 4, 5, 6 factorial. Or if the number is 5 or 4, or right, how many numbers are there that will be divisible by that? Very good. Now, so if I'm able to prove this, this is nothing but product of 5 consecutive integers.
So it is a product
If
factorization.
if I'm able to write it down, this is in the form of 5 consecutive integers, 100% that will work, right? So let's see. N common out, this is n to the power 4 minus 5n square plus 4. Now we know that we can factorize this, and the factor of this is
N square minus 4
n
into
square
n
minus
square
1 and n
minus
square
1.
minus 4.
And
n
that can be
square
factorized further to
minus
get 5
1.
consecutive numbers.
Very good. So this is nothing but n minus 1. This is nothing but n minus 2. So this I can write n minus 2, n minus 1, n plus 1, and n plus 2.
Which is a consecutive in five integers, so that's why
1,
5
2,
consecutive
3,
will be
4,
divisible.
5. So it's
That means always
consecutive
divisible by
1, 2, 3, 4, and 5. So the product of this is 120. So the number will be divisible by 120. Is this okay? We have lots of methods, right? But what I have to use for numbers, that we have to understand. Just we have to see, okay, I have induction. That's very good. We have induction, but why to use induction? Right? If we have some simplest method, I hope you all are getting this. Okay, everyone?
Yes, sir.
Okay, okay. Sure. Next. So this is the first condition or the first concept when we are talking about when the number is divisible, right? Number is divisible by consecutive numbers and all, right? Now, the second on this is, right, the basic concept. If like I'm just writing one number, you all know now 6 divides a square plus 11, right? This you have to, this is, I have written this for any integer a, we have to prove 6 divide a into a square plus 11. the basic of numbers, right? When we have to say this is divisible. Mhm. Very good, very good. Just with the basics, we have to prove this. Done, everyone. See, what I'm saying, this is the same question what we have done in the previous one. How this is the same question? See, when we have to say the divisibility, right? When we have to say the divisibility, this is 6 divides a cube plus 11a. Is this okay? Right? Or can I write this as 6 divides a cube plus this I'm writing as 12a minus a. Is this okay, everyone? This 11a, I'm writing 12a minus 1, but this is divisible by 6. So can I write? Only I have to prove 6 divides a cube minus a only. And a cube minus a.
3 consecutive.
Very good.
Saurabh, you can
So
just
3 factorial divides.
Very good. So these 3 consecutive number is divided by 1 into 2 into 3. That's factorial 3. That value is 6 only.
so we can also use format which states that a square is congruent to
फॉर्मेट
1.
फॉर्मेट आएगा जब करेंगे बेटा that like अभी तो we are starting with the basic things, right? Okay. Okay. So you can, okay, everyone, anyone want to ask anything on this? -11 as -16 plus 27, not bad. Then yes, you can split this into 2 parts, right? But what you will apply now? Because we have to say this will be divisible by 6. So the number will be 1 into 2 into 3. Okay, see. So few more question on this, right? You have to prove 3 divides a, 2a square plus 7. Try this too. 3 divides a into 2a square plus 7. Use simplest thing what we can do. Very good. Use very good. कुछ बहुत प्यारा सा चाहिए पत्यूस ना need a very good method. Done, Krisiv? Wow.
Yes, sir. Same.
Very good. Just we have to visualize the same thing is coming, right? Tanmay, very good, beta. Very good. So, will help me out for this. This, I can rewrite this as 2a cube plus 7a. Atani, very good.
2a cube plus a.
2a cube plus 7a, and this 2a cube I can rewrite as minus a cube plus 7a,
Plus a.
right? So obviously this is three consecutive number. This is minus sign with minus sign, a minus 1, a and a plus 1. Obviously, product of three number, so one of the number must be divided by 3 only. Okay. Okay, everyone. Right? So in the same page, if I'm giving, okay, everyone, right? Comfortable? Kassis, is this okay? Read, Matri, Tushar.
Yes, sir.
Okay, okay. See. So now if I'm giving this, right? A GCD of, you all know the meaning of GCD, na? Is 1. Prove this for any integer a. GCD of 2a plus 1 and 9a plus 4 is always 1. No common factor is coming for 2a plus 1 and 9a plus 4 for any integer a, right? You can change integer a as many as you can, but like you are not getting any common factor between this that we have to prove, right? So please. So one of the person when they will ask of GCD, this is the like for RMO you can say, right, or IOQMA or RMO may you'll get like every year you'll get few questions from this. A very simple question, very simple concept, but and इम्पोर्टेंट ये है कि आजकल अगर आईआईटी के आप लोग देखे होंगे तो आईआईटी में भी फॉर द रिलेशन एंड फंक्शन दे आर यूजिंग दिस लैंग्वेज, राइट? तो वहां पर भी बहुत काम आने का ये होता है, यूज कर सकता है। वेरी गुड, वेरी गुड। प्रत्यूष, वेरी गुड बेटा। This audible, everyone?
Yes, sir.
Okay. See, done. Few of the responses are coming as done. Tanmay,
हाँ सर, बस होने वाला।
Shivang, Shama. See, the GCD, right? GCD means the common factor from both this, right? So can I say this key? Let 1D divides 2a plus 1 and let D is also dividing 9a plus 4. Right. Can I say this key? If D is the GCD of both the numbers, so if D is dividing 2a plus 1, so D must divide 9a plus 4. Right. So it must be divided by both this, right? And D, I can say D is not divided by, D is not a factor of 2 and D is not a factor of 9. Can I say this? Can I say this? D is not a factor of 2 and D is not a factor of 9. Or we can say this, the factors, if I'm multiplying few numbers with this, so D must be also with the factor of this. So D must be divided by 9 minus 8. Oops. D is coming as 1. Is this okay? So we have to choose the number wisely. So we'll get the answer in the quickest form. But the number what we have to choose now, that's very important, right? So like little bit practice is required, but ये जितना प्यारा काम करेगा ना, you'll love this. वो क्वेश्चन है जो like 2-3 pages में we have to do now, we can do in like just in few steps. Is this okay, everyone? Everyone is comfortable with this. You understand the concept behind this. Right? Right. See, what I'm saying now, if D divides 2A plus 1, right? So this is an odd number, right? And D divides 9A plus 4. So this is 9A plus 4. So 9A plus 4, A would be any integer. So when I'll divide this, the second one, with 9, the remainder will be 4. Is this okay? And if I'll divide this by 2, the remainder will be 1. So 100% D is neither multiple of 2 nor multiple of 9. Now, my work is I want to cancel out this A. So what number I have to multiply to both or subtract, right? So get the value as the numerical one. So I'll be able to say that what the D is divisible by that number. Because GCD of any number, if I'm saying GCD of AB, right? GCD of AB will be same as GCD of A minus B and B, or A or B minus A, or like few of the numbers we can multiply with that also, right? Then we will get that. Is this okay, everyone? Okay, now. So now I'm directly coming to the question on this, how the question will work on that. If 13 divides n square plus 3n plus 51, then prove that 169 divides 21 n square plus 89n plus 40. Can we? Want to try this?
Yes, sir.
Please. Oh, great. Now, so just we have to crack this out, Tanmay.
Yes, sir.
Done. May I start? Ah, not bad, but we have to make sure that the remainder will be divisible by 13. But when we are making this as a perfect square, now the remainder will not be the perfect like coming as an integer, right? So we have to split this in such a way we'll be able to get the numbers, right? So may I start this? See.
So 1 minute.
Sir, 1 second.
Okay. We have to split in such a way we can see this is divisible by 13, the first one. With the help of that only, we can go for the second one, right? So if you'll see, right, the first one, n square plus 3n, this is given divisible by 13. So I can say this is n square plus 8n minus 5n minus 40 plus 91. Can I write something like this? Why I'm writing something like this? Okay, see, I can rewrite this as n plus 8 into n minus 5 plus 91. So the difference of these two number is always what? 30. So if I'm taking one number as a multiple of 13 or something, right? Second number will be obviously, right? Okay, that will be always divisible by 13. If this number is divisible by 13, so 100% this must be divisible by 13. So from this, I can say either n plus 8 is divisible by 13 or n minus 5. But the difference between both the numbers are 13. So can I say this is not or, this must be and. Any number is in the form of n minus 5 or any number is in the form of n plus 8 must be divisible by 13. Is this okay, everyone? So we can say ki n is nothing but this is 13 lambda plus 5 ka form. N is nothing but 13 lambda plus 5 ka form. Right? Can I use this number 13 lambda plus 5 ka form in the second one? Right? Try this now. Try this now. Try this now. Now only you have to prove if the number n is in the form of 13 lambda plus 5, then 21 n square plus 89 n plus 44 is always divisible by 169.
Sir, done.
Very good, very good. Everyone, go for that, go for that. Now this is a simple one. Or you can factorize this also. You can take the factors also. May I start?
Sir, 2 minutes.
Okay, okay.
Yes, sir, done.
Very good, Pratyush. Tanmay, done?
Sir, it's going to be.
Answer done.
Done. Rians, very good. Reserve, done. Tanay, very good.
Sir, I am checking for n plus 8 case.
And plus?
Sir, here we assume that n minus 5 is divisible by 13, na?
The same is there, na? If
Acha,
n
sir.
5 is divisible, so 100% n plus 8 is also divisible.
Acha, हाँ, sorry.
Na?
Then done.
The difference between both the numbers is 13. So if one
Yes.
number is divisible to 100%, the other will be.
Sir, miss हो गया, sorry.
Okay. Pratyush, what you have done?
Sir, I just put 13 and plus 5 in the equation,
Very
and I
good.
found all the terms to be divisible by 169.
Very good. Very good. Receive.
So I expanded it and it got divisible by 169.
Okay, not bad. Tanmay, same
Yes, sir.
process, right? Put the numbers and just you are getting the right. Rians,
Yeah, sir, even I put 14 and plus 14 lambda plus 5 as in.
13 lambda plus. Malab, you have put the value in this one.
Yeah, yeah,
Ah.
same process.
Okay. Everyone getting this. Tanay,
Yes, sir. Same way.
same. Utkarsh, Avijay. Okay, everyone. So comfortable. Now.
Yes, sir.
So this is one of the area like where we have to make sure how you have to get the numbers as the divisibility cases, right? If I'm giving you, find the largest number, largest positive कर लेता हूँ, positive number m such that n cube plus 100 is divisible by n plus 10. N cube plus 100 is divisible by n plus 10. You have to find the largest n for this. Positive number n. Wow, very good. Sivan, very good. Just send me the working. Very good, Kasev. Not bad, not bad. ऋषभ बट थोड़ा सा उसकी वर्किंग और आगे जाएगी बेटा. Yes, 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 Kasev. Very good.
Sir, or working in the sense?
आंसर अभी नहीं आया बेटा.
अच्छा.
Very good, Sanjana. Very good. Okay. Let's start. Let's start. Piyush, Rishabh, very good, everyone. Katyani, done.
Adjusting.
Okay. Okay, okay. नहीं 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 सिंपल कर दो. संजना, what you have done बेटा? संजना.
Sir, I'll send my work in just 1 second.
फिर से.
Yes, sir.
Yes, what you have done?
So n plus 10 divides n cube plus 1000. So n plus 10 divides n cube plus 100 plus 900.
Mm-hmm.
So n plus 10 divides n cube plus 100. So n plus 10 divides 900. So
Very-
n will be equal to 890.
Very good. So can I say this? N plus 1 is 0 mod n plus 10. Obviously, now this is already divisible. So n is congruent to minus 10. Your previous question, what we have done, just I'm using that only, na? Right? Now, cube both side, n cube congruent to minus of 1000 mod n plus 10. Or n cube plus 100 is congruent to minus mod n plus 10. Is this okay?
Sir, I've sent something in the chat.
No. Very good. Very good. So 900 must be divided by n plus 10. So obviously the value of n is equal to 890. Is this okay, everyone? right? So 890 plus 10 will be 100, right? Very good.
Sir, I just joined again. I got disconnected due to power cut. Could you explain it again?
But this was the question. Find the largest positive integer n such that n cube plus 100 is divisible by n plus 10, right?
Yes, sir.
So we know that n plus 10 is always divisible by n plus 10. So n is congruent to minus 10 mod n plus 10, or n cube is equal to minus of 1000. So n cube plus 100 is equal to minus 900 mod this. So 900 must be divided by n plus 10. So obviously,
Yes.
right?
890.
No?
Thank you.
Now, so like little bit you have to work on that, right? The next question is coming to you. So everyone careful, right? Prove that there is no integer a such that a square minus 3a minus 19 is divisible by 289. Divisible by 289, right? 289, 17 of square of 17, right? So divisible by this, that's a hint. I'm giving you 17 square. So just in the,
Sir, it is a square minus 3a minus is 19.
yes, better. A square minus 3a minus 19. Minus 90. Minus 90, right? A square minus 3a minus 19 is divided by 17 square. Right? Same what we have done is the previous to the previous one. How could you prove this is not coming as a perfect square for any of the case? Rishabh?
Sir, any any perfect square has to be a multiple of primes to the power of even any perfect square. So, sir, I start off like a square, b square, c square, up to how much soever terms are there, and then I have 117 outside. And for it to be perfect square, the bracket which I have is like 5 plus 4 into 17x. That is also has to be divisible by 17 for perfect square. but it is not divisible because it's 5 plus 17.
Not bad, not bad.
Sir, I've said my explanation.
How
मोटर का बैटरी का
ये Aryan, you have given a statement, very strong statement you are giving, n minus 3 congruence to 19 mod 289. How you can say this?
Sir, I said it can never be.
Why? Why? मतलब how
No,
come
sir,
to
because n into n minus 3, we can take several examples such as 19. N into n minus 3 can never be 19. First of all, since 19 is prime, then
not
307.
not enough, not enough,
1 minute.
not enough. Now, Sanjana, just you have put this is equal to 0, then only you are getting na. But maybe this is not equal to 0. This is coming as some I square.
Okay, sir. Sorry.
Na? So might be we are not getting that na. So remember this question na. Remember this question na. I have taken two of the factor is one is n plus 8 and other is n minus 5. So the difference between both this is 13. So one is divisible by 13, other must be divisible by 13. So the same way I have to work, I have to take a difference of a square minus 3a as a split. I have to split this as a 17. So one will be divisible by 17, so other must be divisible by 17. Then only I have to concentrate for the constant part. Right? The constant part, right? You understand my point? Now work on that, work on that. I have to split a square minus 3a in such a way, one must be divided by 17, then other must be divided by 17. That is possible only if the difference between both the number will be 17, right? So that will work, 100% that will work, and always that will work. Yes, yes. And the constant term is not divisible, so we can say this is not divisible by 17 square or something like that. Okay, okay. Can I see? So this is a square minus.
So just a minute.
Okay, 19 is to 10 and 9. Then Vijay. Voice is not coming, Vijay.
Hello, sir.
Now it's coming.
Sir, a square minus 3a minus 10 को फैक्टराइज कर सकते हैं. A square minus 5a plus 2a plus a square minus 5a plus 2a minus 10. So factors are a minus 5 and a plus 2 minus 9. So जो a minus 5 और a plus 2 का डिफरेंस है वो -17 नहीं आता.
देख, प्रत्यूष ने बड़ा अच्छा काम किया. प्रत्यूष ने एकदम क्लियर कट, he has given the like perfect solution. Very good बेटा, बहुत अच्छे प्रत्यूष. प्रत्यूष टू ऑल कर दो डायरेक्ट मैसेज को. See what Pratyush is writing. Pratyush is saying is, sir, a square minus 3a, right, minus 19, whatever it is, the constant, he is not very much interested for that. But a square minus 3a, he is writing this as a square plus 7a minus 10, right? Minus of 70, then plus 51 is coming plus. I can split this into two parts. One is a minus of 10 and a plus 7 plus 15, right? So you can see the difference between both the number is 17. So if this is divided by 17, so 100% this must be divided by 17 and 17. So if a minus 10 is divisible by 17, then it must be a plus 7 must be divided by 17. Both are divisible by 17. If both are divisible by 17, so this complete number is divisible by 289. But the remainder of this 51 is not divisible by 289. So this number is not divisible by 289. Can you believe this? You all are doing the question of RMOs. ये जितने क्वेश्चंस हैं उस वो क्वेश्चन प्री आरएमओ की भी बात नहीं कर रहा हूं, राइट? And these questions are very simple, but we have to know the language exactly how this will work. Yosef, want to ask anything?
No, sir.
Comfortable? See. Write down. Okay, note down, please. So the numbers and the like, if you go for the pre-RMO questions, right? Maximum they will ask with the something like this. Sn is given as n square plus 20 n plus 12. N is a positive integer. Positive integers, right? If Sn is perfect square, then find sum of all the possible values of n. Right? Last question it was like, what to say, perfect square वाले form में गड़बड़ हुआ. That's the reason I'm giving this question. Yes, yes.
So done.
Very good, very good. Send this, send this.
Yes, sir. I'll write it in chat because I'm right. I'm using mobile data.
Okay, Tanmay, very good. Okay, everyone. Very good, Tanmay. Should we start? Should we start now?
Sir, 1 second.
Wow.
Sir, I've sent my solution.
Hmm. Okay. Okay.
Sir, is my solution correct?
Yes, yes, correct. But little bit more we have to do in this. See. Okay, see. Uh, this question or this type of question, 100%, these are very important question and very simple question. And we are lucky in this case because it's given that only this is a perfect square and the numbers are coming in such a way like this number 20 is you can factor this. Maybe possible if you'll get some number as 11 or 13 or 17 in this. Then we have to multiply the complete number by 4. Can I repeat this or it's okay? Maybe this number 20 in place of 20, they will give you 11 or maybe 19 or something. Then we have to multiply 4 with the left side and right side. Then we have to go for this, right? So in this, I can say n square plus 2 into n into 10 plus 100 is equals to I square plus 100 minus 12. So this I'm getting as n plus 10 the whole square is equal to I square plus 88. So, right, n plus 10 the whole square minus I square is coming as 88. Since n is an integer and the plus 10 is there, so 100% I is always an integer, right? So this is n plus 10 plus I, or second is n plus 10 minus I is equal to 8888. Now, product of two positive integers, because it is given this is positive, so product of two positive integer is coming as 88. Now, can I say this? I can factor this as 1, 88, 2, 44, 4, 22, and 8, 11. So if one number is 1, obviously the lowest one is this one. So this is 1. So this will be 88. But the sum of both the numbers are odd. So we can't take this because sum in the left side, the sum will be 2n. So first and last is not possible. The possibilities are only this. When I'm saying n plus 10 plus I is 44, then n plus 10 minus I as 2. First one. And second, I'm saying n plus 10 plus I is 22. Then n plus 10 minus I as 4. Now we have to solve both the equation. I hope you all are getting this. mean, or I else I can add all four, right? Then I'll get the value of n. $16, I guess 16 is coming on this. Is this okay, everyone?
Yes, sir.
Right? So careful. This is very, very simple question, but very important question.
Sir, but it was said the sum of n factorial, right?
Sum of why n factorial?
Sir,
Sum of possible.
oh, it is only, oh, it's n. I misread it as n factorial.
Sir sent something in the chat.
88 and 1 if you'll take now, then see. One number you are saying 88, so obviously the larger one in this case is n plus 10 plus I is 88. And second number what I'm saying is n plus 10 minus I is 1. If I'll add both the number or subtract both the number, so what I'm getting is odd there, right? So 2I is equal to odd. I is an integer, so it's not possible.
Okay, sir.
Right. So that I said, okay, like for odd, this is not possible. So, but the simple question, I guess. When a perfect square of the numbers are coming, then like we have to work on that, right? And the divisibility, right? Divisibility, most of the case, you'll get a divisible by 7. Or divisible by some numbers 13, divisible by 17, as we have done in the previous questions, right? So those questions, right, the not a very simple one, but obviously we have to work on that, right? Or, okay. So this is about the divisibility conditions and all, right? 2 more question I have for this concept. So thoda sa fast karke, we have to do that, right? First one. Okay, everyone? X1 is the positive real number and every integer n greater than equal to 1, xn plus 1 is equal to 1 plus x1, x2, x3, xn minus 1, xn. If x5 is equal to 43, find x6.
सर ये कोई देखा है
Huh? Yes. Same question. This is positive real number, na? This is not, this real number is the integer.
Sir, I'll send the
Very good. Very good.
So 1 minute was
I understand what you want to say. Very good, Katani. Very good. Yusuf, very good. Very good, every Rishabh, I guess. Good. Very good. Only this integer will work for that, right? Tanmay, very good. Arey, wow, everyone, very good. Very good, everyone. Very good.
The solution
So good, 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 good. The number 43 is working, right? Raj, थोड़ा सा calculation check कर बेटा. Utkarsh, very good. See, x5 is 43. So x5 is 43. 1 plus x1, x2, x3, x4. So 43 minus 1 is equal to x1, x2, x3, x4. This is coming as 42. Right? So what is this x6? Product of x5 plus product of all the 4 plus 1. So this was 43 into 42 plus 1. I guess something like this is the answer. Tanay,
yes, sir, which is 180.
very good, everyone. Very good, right? Very good. Next one. This is again IUQM, right? Again IUQM. Find integer n, positive integer, right? Positive integer n, such that 2 to the power n plus 5 to the power n minus 65 is a perfect square.
Sir, are these
ये
those
2019
brackets?
का है
हाँ
हाँ सर 2019
इसे 2019 का लग रहा है
No,
2019.
not 2019, but हाँ IUQM का क्वेश्चन.
चलो ब्रैकेट्स है या फिर
Mod है बेटा.
और
2 to the power n plus 5 to the power n minus 65 is divisible, is a perfect square. Take your time, Aryan. Don't be in rush. Take your time. Yes, 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 Sanjana. Receive, you have to be make sure.
Yes.
Only these are the answers, right? Yes, yes, Sanjana. तन्मय और थोड़ा बेटा.
So what's my answer?
No, Aryan. Very good, Katayani, very good. But little bit more work required on this. थोड़ा सा और बेटा. Okay, let's start. Let's start. See. So we can see in this case, right? This is not okay. Like okay. So it's a hit and trial method or something you have used. Anyone, please. Open for all of you. Utkarsh.
Sir, try.
तो हिट एंड ट्रायल
Okay.
मतलब अभी मैं कर रहा हूँ.
Okay. So you have to make sure that after this we're not getting any answer, right? Because like नहीं तो वो तो बहुत बड़ी वाली प्रॉब्लम हो जाएगी ना कि we are getting few of the values 2 and 4, right? 2 and 4, like most of the answers are coming as 2 and 4, but maybe possible कि more numbers are there, right? So okay, so first thing we can say in this, obviously the number must not be odd. Why? Number is not odd.
It has to be even.
Right? Why? Because if number
even plus odd minus odd.
No, well, exactly. The number would be odd when the number is odd. So let some number is odd, then this will be ended with either 2 or 8. 9?
That will end with 5 and that will end with 5. So 2 or 8 will never form a perfect square.
Exactly. So 100% we can say the odd numbers are not possible in this case. Right. So only the numbers are even that are possible. So we have to like एक थोड़ा तो reduce down. मैंने अपने पूरे numbers को कर लिया. It must be right. All the numbers are even. ना? So obviously you have tried n is equal to 2 and n is equal to 4. So directly you are getting the the numbers. What number I'm getting for n is equal to 2. Right, and n is equal to 4.
N equal to 2, sir, we get 36 small. Minus 36 small.
Very good. Or for n is equal to 4, what I'm getting?
576.
576. Right? But we have to make sure that if n is greater than, right, n is greater than this value, so we have to make sure that for n greater than 4 or greater than 5, or the value from 6 to any of the even number, it's not possible. Right? We have to make sure of that. So what I'm saying, okay, 2 values I'm getting, so that's, we are lucky that we are getting 2 values. But I square, the integer square is equal to right? If I'm writing this as 2 to the power n plus 5 to the power n minus 65. Why the number 65 is only given, right? That we have to see, nahi? So this I can write I square is equals to 2 to the power n plus 5 common out. So 5 to the power n minus 1 minus 13. Right. So this number is in the form of something, right? When I can say the number is 5. This number. So this 13, I can say this 13 is nothing but 25 plus 12, minus of 25 plus 12. Right, minus of 25 plus 12. So this I square is equal to 2 to the power n plus some n into, right, factor of this with 12 into 5. The factor of some numbers n1, n2 into 60. Right? So 2 to the power n plus n1 into some 60 number is coming. So what is the meaning of this? Right? If the number is even, so I square minus 2 to the power n is equal to n1, n2, and some number 60 is coming. And since n is even, so I can factorize this number as I minus 2 to the power n by 2 and I plus 2 to the power n by 2 is equal to n1, n2 into 60. Is this okay, everyone? Is this okay, everyone?
Yes, sir.
So what is the meaning of this? The factor one
Either of the two values must be 60.
so this is not possible. So if n is greater than 5, this is not at all possible. So whatever you have found, that will be the value. So only the numbers are 2 and 4. Only the numbers are 2 and 4, what we are getting from this. Okay. Right. So one of the factor has to come as 5. So for greater than the value, n is not possible. So both the numbers are even, so n must be even. So it's not possible with that. I have factorized this in the form. I'm getting 2 factors of the number. Okay, this is right. So few more questions we have to do. I'll send the question on this, right? So now I'm coming into the next topic, right? The next topic is congruence of integers. Congruence of integer means basically the divisibility cases. Divisibility cases, we know that we can write any of the integer n as m into q plus r, where r is the remainder, right? If the number is given, n is the given number, right? And when this is divided by m, right, the quotient we are getting q and remainder we are getting r, and this r is lying between 0 to m, the first value and 0 and division with reminders, right? The reminders are there. So actually, when I'm saying A congruence to B mod M, what is the meaning of this? You all know this meaning A minus B equal to some K into M. Is this okay? If I'll subtract A and B, so the division will be some K into in terms. Or I can say A minus B is congruence to 0 mod, or I can say M divides A minus B, right? This is the language of congruence. And few of the basic properties. Is this okay, everyone? Right? Few of the basic properties, right? if I'm saying A congruence to B mod M, मतलब मैंने अगर किसी नंबर को डिवाइड किया, if I'm dividing by M, I'm getting the remainder A, and some other number I'm dividing, and the same remainder I'm getting, as well as if I'm saying कि B giving the same remainder with mod M, so it's obvious I can say A congruence to C mod, right? Right? You can add or subtract both the numbers, right? A plus C congruence to B plus D if I'm saying mod M, right? Since if I'm saying A congruence to B mod M and C congruence to D mod M. So I can add both the numbers or subtract also mod M. We can give the powers, right? But we can't divide this, right? We can give the power also, right? We can multiply with the numbers also. So every time you will get the same result of this, right? This is the basic of congruence, right? So what is the use of congruence? When we have to find the remainders, when we have to find the numbers divisible or not, or the powers are given something like 3 to the power 2000. Right, when I'm dividing this by 13, there is a remainder. Right. So this is the basic of congruence when we have to say the heavy powers are given and we have to find what is the number coming into this. So just we have to start with the basic, but when we will learn Fermat theorem or Euler theorem, then the question will be very simple. Starting, I can say 3 to the power 2000 when divided by 13. So what we have to see, when the power of 3 I'm taking, one of the number nearest to the multiple of 13 is coming. So if I'm able to make the relation as when I'm dividing some power of 3 and getting the remainder 1 or minus 1, so that will work for me. As I can say 3 to the power 3 is 1 mod 13. Is this okay, everyone? 3 to the power 3 is 27, right? And 27, when I'm dividing this 27 by 13, so obviously I'm getting 1 as the remainder. And this, we have to reach to 2000. So I can say 3 to the power 3 and 666 is congruent to 1 to the power, as we said, we can give the power also, mod 13. So this is 1998 congruence to 1 mod 13, right? But what we have to reach to the power of 2000. So I have to multiply this by 2 square, power of 2. So mod of 13. So this is coming as 9 mod 13. So the answer is 3 to the power 2000. When divided by 13, you are getting the remainder as 9. Is this okay? This is one of the simplest example. I hope everyone is getting this. Okay, everyone?
Yes, sir.
Yes, sir.
Right? So now we are coming into this. Now the few of the question will be very simple, right? You will be warm up with this, then you will gradually go into the real question on that, right? 2 to the power 69 plus the number n is divided by 127. So what is the value of n such that 2 to the power 69 is divisible by 127? Very good. Say
So we have to tell positive n.
positive. Very good everyone. नुस्खा एक बार चेक करना बेटा. Check the number. तने एक बार चेक करो बेटा. And everyone. See, in this I can say, later on I'll add, right? Just I'll see what I'm getting for 2 to the power 69, right? 128 is a number, we know that that's nearer to 127, and 128 is coming as 2 to the power 7. Right, 2 to the power 7 is 128, then concurrence to 1 mod 127. Is this okay? And I have to reach to the number 69, right? So 69 I have to reach, so I can give the power 9. 1 to the power 9 is again 1 only. So 2 to the power 63 congruence to 1 mod 127. Or I have to multiply with the number 2 to the power, I have to reach to 2 to the power 69. So 2 to the power 6 is the number mod 127. So 2 to the power 6 is the remainder. Right? 2 to the power 6 is what? 64. So I have to subtract this 64, 127. I guess you are getting as 63. Everyone getting this? Okay, everyone?
Yes.
Right?
Yes, sir.
Very good. Right? Now, find remainder when 5 to the power 99 divided by 13. Very good, Patyus. Very good, everyone. Remainder must be always positive now. So if answer is coming as negative now, so you have to write down as the positive one. Now remainder must be always positive. 5 or 8?
8.
See, this is 5 to the power. We know that 5 square is congruent to minus 1 mod 13. 5 square is 25, 13 26, right? So I have to give the power 49 both sides. So this is coming as -1 to the power 49 mod 13. So this is coming as 5 to the power 98 congruence to -1 mod 13. Multiplying with 5 both side, I'm getting -5 mod 13. But we know that this must not be negative. So 8 is the answer. Right? Everyone, very good, very good. So you all are comfortable with this. The last question on this. 7 divides 2222 to the power 5555 plus 5555 to the power 2222. SMO question. Right? Question from Singapore Mathematics Olympiad. Right? Find the remainder when divided by 7. Very good. Very good, Sanjay. This is a very famous question. So always you'll get this question, right? And here and there, always you'll get this type of question. I hope everyone is getting this very quickly. Hey, what remainder you are getting when you are dividing this 2222 by 7?
3.
3. So just you have to see 3 to the power 5555 plus the second one is
3 to the power 222.
2222, right? Right? So let's see, like obviously you all are getting this divisible by 7, right? Can I do the same? Just Sanna said so many times he has done this question. Just I'm writing this, right? And just adding this and subtracting this. So I have to subtract and add, right? Can you see this is always divisible by 7? Can I say this? Can I say this is always divisible by 7? So only I have to prove this must be divisible by 7. Right? Or this is divisible by, because if I'll take common out 1, 1, 1, 1, or then this is coming as 4 square minus 4 to the power 5. If 4 square is common out, right, you are getting this 4 to the power cube. 4 cube is 64 minus 1. This is again divided by 7. So everything is divided by 7. And not by like this congruence method, just adding and subtracting. It's okay. So I've given the new
Sir,
method.
could you show the solution one time?
Huh?
Although I folded, but I want to write the solution.
Voice is not coming. एक बार फिर से बेटा.
Sir, can you show the solution one time? मैंने एक line लिखा हुआ है.
Yes. See.
Can you
Just
show the solution one time?
I am 47 to the power 37 to the power 27 when divided by 11 leaves the remainder. Now, this is the question.
सर आपने एक बार ये दिया था.
ये question? Very good. So this time, answer must be perfectly correct, right? Without any doubt. Please, go ahead. Yes. Utkarsh, very good. Very good, Aryan. For concept building, now this is a very good question. That's the reason I have given this. 47 to the power 37 to the power 27 when divided by 11 with the remainder. Please check your answer. Basically, what we are doing. May I start this? Okay, everyone?
Sir, 1 second, sir.
Very good, reserve. Accused, very good. Very good, everyone. See, we know that when I'll divide 47, the base one, the 47 by 11, I'm getting 3 to the power 37 to the power 27, right? 3 to the power 37 to the power 27. That I have to find here exactly 3 to the power. Now I have to concentrate on this. It's 37 to the power 27, but I have to make sure what is the power of 3 would be there that will give me the answer in the nearest form of 11. So 3 square is 9, 3 cube is 27, not coming, 3 to the power 4, 81, not coming, 3 to the power 5 is 243. Yes, 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 243 to अच्छा लग रहा है नहीं? The when I'll divide that just by 11, 22, 2, 3, 2, 22, 1. Wow. So I have to make sure that this number I have to get in the power of 5. Means simply just I have to see, right, this. What is the number? This number is coming when I am dividing this by 5. What is the remainder I am getting with mod 5? Is this okay, everyone? Why I'm going for 5? Right? So this is nothing but 2 to the power 27. And 2 square, right? 2 to the power 27. We know that 2 square is 4, right? I have to find this one. So 2 square is 4, that is minus 1 mod 5. Right? And I have to give 13 power both sides. So I'm getting 2 to the power 26, 1 raised to minus 1 mod 5. And 2 to the power, this will be minus 2 mod 5. Minus 2 mod 5 is same as 3 mod 5. Is this okay? What is the meaning of this? The meaning of this is if 37 to the power 27 number is coming as 5k plus 3 form. Means our original question is coming as 3 to the power 5k plus 3 form. or 3 to the power 5k into 3 cube form. 3 to the power 5 giving you the remainder 1, 3 cube is giving you the remainder 27. Right? And what we have to do, we have to divide this by 11 and we have to see. So 27, I'm dividing by 11, 5 mod 11. Very simple question. Just you have to see what the power has to get. What the power has to get. And if finding any problem with this, please ask. This is the basic question. When you have to get the power of a power of a power, only you have to concentrate with the basics. Okay.
Yes, sir.
Okay, everyone. Anyone want to ask? Anyone want to ask? Anushka, is this okay? Okay, okay. Kasil, this is okay?
Yes, sir. So let's send the answer.
Answer is 5, na?
Yes, sir.
Very good, very good. See. So obviously, right, these are very simple questions, right? In this question, one more. 14 to the power 14 to the power 14. Last 2 digit of this answer. Y dividing with 5. See. We know that 3 to the power 5 is giving you 243. And 243 is, right, 243 congruent to 1 mod 11. That's the reason I'm going on the power of this, right? 14 to the power 14 to the power 14, last 2 digits of this number. This is a good one, right? This is a good one. So take your time, relax. Little more work required. This is Raj, little bit more work, beta.
So just a minute. One.
I'll not use Euler-Totti function. Without that, I'll do that. Now you can use. You can. If you know, you can go ahead with that. But we have to study. That's the reason I have to hold that. Very good. Very good. Send the solution. Send the solution. the same thing you have to do what we have done in the earlier, like in the last question only.
Order.
Oh, Chrisip, use. I guess you can use better method on this. Go for modulo. Go for everyone. Go for modulo 25.
Okay, sir.
Because this is the number is always divisible by 4. So only I have to see the last two digit means we have to find when we are dividing this number by 100, what number I'm getting, right? What number I'm getting. So what I'm saying is 100 is the number that is multiple of 4 and 25. And this number is always divisible by 4. So only I have to see when I'm dividing this by like 25, what remainder I'm getting, then we have to work on that. Anushka, एक और try बेटा, एक और try. May I start? A bit more, a bit more.
सर मेरा सही है क्या?
सही यार है. Let's start. May I start?
So 1 minute.
Okay, okay.
Sir, is my answer correct?
थोड़ा गड़बड़ हो रहा है. उत्कर्ष, where are you? Hey, listen. बहुत बड़ा गड़बड़ हो रहा है, चेक करो. लास्ट डिजिट ही मेरे को वो नहीं हो रहा ना.
सर 10th digit गलत है अब.
Chalo, 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 chalo. No problem, no problem. See, what I'm saying, when
Sir, done. Using other method.
very good. This one divided by 100, then what is the last two digit? Obviously, we can go with the 100, but we know that this 100 is not a prime number. So prime numbers, we know like we can go with one by one. So this co-prime number and of this is 25 and 4. So I can see this one divided by 25 and 4. See the method now. Yes, this is CRT, Chinese remainder theorem. But I'm not giving the name of Chinese remainder theorem. I'm not using directly the formula of Chinese remainder theorem. Just just through the question, I'm just giving you exactly how this will work, right? So this is CRT only, but I'm not giving the name CRT. Just I'm going through the question. Just I'm giving you an example exactly how you have to solve, right? So just two factors are there. And in CRT, it may be 2 or 3 or 4 or 5 or n factors are possible. Right? In this question, I'm getting two factors only, 25 and 4. So since the number is always divided by 4, okay, that will be separate part, right? Now I'm just taking care of this only. When I'm dividing this by 25, what remainder I'm getting, right? So before that, you know that 14 if I'll do 14 square, so 14 square is congruent to 196 minus 4 mod 25. Okay, everyone? Right? 14 square. Right? Minus 14 square means minus 4 square is 16 into 14. What is the value? This is coming as 224. This is coming as minus 1 mod 25. So what power we have taken for this? ये power 4 आ गया, ये power 1 आ गया, तो total power is 5 is minus 1. So I can say 14 to the power 10 congruent to 1 mod 25. Up to this. Is this okay, everyone? यहाँ तक के स्टेप में क्या सबको सही है? I have taken 14 square, that's coming as minus 4. Then 4 minus 4 square is 16. 16 into 14 is 224. Now 224, I know that that will be congruent to minus 1, not 25. So the number is coming as minus 1, but I need plus 1. So I'm going with the square of that number. So we have already taken up to this step, we have taken the power 5. इसके पावर में 2 दिया and 1 power दिया, तो total number of power is 5 and squaring that power, so I'm getting 14 to the power 10 congruent to 1 mod 25. Is this okay? Means ये वाले 14 जो है इसके powers we required is 10 and multiple of 10, if I'm getting multiple of 10 on this, right, so my work will done, right? So now I have to concentrate on this. I have to make this as 10, right? Means like if I'm working on that, so what I'm saying now I have to work for 14 to the power 14 mod 10. What number I'll get from this? Right? This is the question only, na? Okay, everyone? So 14 square, right? When I'm dividing this by 10, so I'm getting 6 mod 10. Right, and 14 to the power 14 will be 6 to the power 7, na? 6 to the power 7 congruent to
6 mod 10.
obviously always 6 mod 10. Right, that's always give you the number 6 mod 10. Right, means what I'm getting, the number is 10p plus 6. This number 14 to the power 14 is in the form of 10p plus 6. Can I say this? Right, this 14 to the power 14 is in the form of 10p plus 6 form. Means what we require, right? So this is the power. What power we are getting? This number is 10p plus 6 form. Is this okay, everyone? Is this okay, everyone? Means we have to find 14 to the power 10p plus 6. And we already seen 10 to the power 10p into 6, 14 to the power 6. Right? This number is congruent to 1. Only I have to find 14 to the power 6. 14 to the power 6 is minus 4 into minus 4. Because 14 square were coming as, right, 64 minus 175. This is coming as 11 mod 25. यहाँ तक के स्टेप में up to this step, anyone getting any problem to please ask, because after this we have to go for CRT, Chinese remainder theorem. I'll not use the Chinese remainder theorem directly, but indirectly will go for the CRT. Then you can understand exactly what this CRT or Chinese remainder theorem. Up to this step, anyone finding any problem, I'll suggest please note it down. If you are finding any problem up to this, please ask. Right, so this number is coming as 11, right, when dividing by So this is coming as 11. Or I can say this is 25 cube plus 11. Six to the power 7. Where this is right. 6 to the power 7. It's the question I have to find 14 to the power 14, right? In this, we have 14 square. So what power I have to raise to both this, so I'll get this one. So power 7 I have to raise now. The power 7 I have to raise to the power I am giving 7. So I'm giving this. Okay. Okay. Then after this, the steps. Now, okay, everyone. Okay, everyone. Comfortable, everyone?
Yes, sir.
Now, see. Means if in this case I'm saying right like now the number is in the form of 25t p मैंने ले दिया था ऐसे 25t plus 11 the number is 14 to the power 14 to the power 14 is in the form of this, but when I have to divide this by 4 I'm getting this, right? When I'm dividing this by 4, I'm getting this, means the each and every number, I need each and every number is in the form of 25t plus 11 that congruence to 0 mod 4. So the number must be divisible by 100. Okay. Okay, everyone?
Yes, sir.
Means if I'm dividing this by 4, so what I'm getting? P minus 1. 25 I'm dividing 4, then this is giving you 14, 24 is divisible, so only T. And this 11 when I'm dividing by 4, I'm getting minus 1. So this one belongs to 0 mod 4 means T is equal to 1 mod 4. Or I can say the number is in the form of, right? Number is in the form of 4T plus 1, right? All the numbers is in the 4T1 level, right? 4T1 plus 1 already taking the T as this T is coming as 4T1 plus 1, right? This T is coming as 4T1 plus 1. Now putting this number here 25 4T1 plus 1 plus 11. So this is coming as 100T1 plus 25 plus 11. So this is 100T1 plus 36. So this number must be, when divided by 100, this will always give you the remainder 36. Is this okay?
सर
Mm-hmm.
सर आपको 25t plus 11 0 mod 4 के बराबर कैसे आया?
वो क्योंकि ये नंबर जो हमने लिखा है यहाँ पर बेटा, what this number what I am writing in this, right? This number is nothing but 25t plus 11.
Yes, sir.
And this number when divided by 4 giving this 0, right? 20 like 14 may you'll get 2, and 2 to the power 14 to the power 14 that will contain like more than 2 2s.
Yes,
so
sir.
this is always divisible by 4, right?
Sir, okay, sir.
Right. So what I'm saying, if this number is in the form of 25t plus 1, if this is divisible by 4, so this must be giving the congruence 0 mod 4. Then only I can say if this is divided by 25 as well as 4, then only this will be divided by 100, because no common factors are there, right? So the same number has to behave like this. The same number, this number has to behave like this only, then only I can say this is divided by 25 is okay. Now it has to be divisible by 4. Then only I'll get the number. So now this number is following the rule of 4. That's the reason I'm giving. Is this okay?
Okay, sir. Thank you.
बहुत सारे different methods है. We have not many methods are there, right? But obviously, like we have to do something in the form of you can understand this very easily. Okay, everyone.
Yes.
Now, anyone want to ask anything on this? So try this one. 257 to the power 33 plus 46 whole to the power 26. When divided by 50, leaves the remainder. When divided by 50, leaves the remainder. Very good, Anushka. Very good. Very fast, beta. Very good. Very good, Patyus, Aryan. Very good, everyone. Very simple question. इतने time नहीं लेने चाहिए. Everyone, do it fast. Do it fast. Rishabh, very good. Okay, Sanjana. Rishabh, very good. Done, everyone?
Yes, sir.
Very good, Sanjana. Very good. Very good, everyone. Very good. I guess सभी के आंसर आ गए ना? This is nothing but 7 to the power 33. And 7 to the power 33 is 7 square is congruent to -1 mod 50. Right? 7 to the power 32 is congruent to 1 mod 50. And this will be what you are getting as 7. 7 mod 50. And 46 is nothing but minus 4 mod 50. To overall, what I'm getting 3 to the power 26. That I have to find. So this is 3 to the power 26 when dividing by 50. What? Last 2 digit, na? At any last 2 digit. Now 3 to the power 26. Three to the power 4 is what? Done, everyone? 81. Right?
Sir, we can go with 3 to the power 5.
Very good.
It will give us minus 7.
Minus 7. Right, and then minus 7, square of this will be 25, and then I guess 29, na?
Yes, sir.
Yes, sir. Sir, in this, can't we go with 25 mod 25 and then we'll choose the odd option?
Good. You'll get the same thing, same answer. No problem. But well, anyhow, right? We can go with that, right? Possibly we can do something, right? Okay, everyone, right? So these are the questions when we have to go with the powers and all, right? And now I'm saying like when we have to go with the power greater than of these powers, then again we have to do something, some extra work that will count on, like congruence and the modulus we have to use, right? Modulo of the function. So GCD मैंने कर लिया, divisibility हो गए, congruence is done, right? CRT is done, but in a different way. We have gone through that, right? So next we will in the next one session we'll go with Fermat, Wilson, and the Euler, right? Then maybe if possibly we will be able to complete up to quadratic in this Saturday only. We'll do the class, obviously, for the long hours again, 2.5 or something. I'll try to complete this on Saturday, this Saturday only. Saturday, or I hope everyone is comfortable with that. Huh?
Right.
Saturday?
Yes, sir.
Yes,
So
sir.
Saturday again, this timing only, right?
Yes.